It's time for Pure Performance.
Get your stopwatches ready. It's time for Pure Performance with Andy Grabner and Brian Wilson.
Welcome to another episode of Pure Performance. This time, unfortunately, without Brian, who couldn't make it today, but I wanted to have the opportunity to record another one of our one-on-one sessions, and I was lucky enough to actually catch my colleague, Daniel Kahn, in our new Detroit office, and that's where we are sitting actually right now. And hello, Daniel.
Hello, Andy.
Hey. It's really, I think a coincidence that we're both here at the same place. And I would really have loved to have Brian on the call as well. But we did, a couple of weeks ago, we recorded a session with you on Node.js, like one-on-one on Node.js, which was very enlightening.
Yes, and I was too long with that, right? And now we have to make serverless
exactly.
like in a new session.
Exactly. So this brings me directly to the topic. So this session is about one-on-one on serverless, and you have been working on the topic serverless. You are a technical lead within the Innovation Lab on serverless technology, and so I guess from the people that I know, you probably have most of the experience. And so I would like to actually get started with enlightening people what does serverless actually mean, what are the main use cases, and then later on we want to little talk about the monitoring challenges. But let's start with what is actually serverless.
Yeah, right. So serverless is currently still, so everything I say today might be wrong a few days later, because it's just a very kind of fast-moving field. It's very hyped currently. I think also it will kind of find its spot at some point. Currently, everyone talks about serverless. Serverless. Let's look a little bit at the history of all those services we know. We had platform as a service, for instance, and a little bit later. So this more or less provided you a full platform that did run your applications. A little later, we had something like backend as a service, for instance, where you could do authentication or session handling or state management. So it was already kind of a fraction of an application that was handled by some servers you consume. And now, and this is what serverless actually is, we have something we would call function as a service. Function as a service means that we really kind of make it even more fine granular, raise the granularity, or what do we do?
We make it even more small. Yeah, we make it smaller. I understand what you mean. So basically,
we make it smaller. So the trend is always kind of make everything one time more smaller again. So like that, coming from an application to platform as a service, backend as a service, and now we have function as a service. So this is really like microservices on steroids, most probably. You can call it like that. So, and the thing, a function as a service is that you really don't really have to care about the platform or anything this thing is running on. All you care is one single function that is executed and that does something for you, does some business logic work here. And this is, I guess, most probably the finest granularity by now you can reach when building applications, actually.
So if I reiterate what you just said, I think that I like the you said backend as a service, right? These were services that I would assume were typically provided by some providers like authentication, where you basically made a REST call, and then this was a service that could authenticate, state management, and all that stuff. And now we make it very easy for developers to focus on a particular function, keep it small, keep it simple, focus on one particular task. Which also means that this is kind of falling into this paradigm of writing microservices that are really small, dedicated to one purpose, and then you will be able, because they're kind of independent from each other without state, this is a perfect candidate for scaling up and scaling down, the classical 12-factor app, right? That we talked about.
Exactly. So this 12-factor idea very much also plays into this serverless topic after all, especially when topics like that it's, for instance, stateless. So a function, or let's start at the beginning. Let's talk about what a function technically is.
Yeah.
So, and I'm talking about Node.js mainly here because it's a very popular platform. It's also very a very good fit for serverless, and I'm mostly talking also about Lambda here. It's provided by AWS. There is also like Microsoft's functions. So technically everything kind of works the same, but let's focus on that. So in Lambda, your function, you create a function that's nothing else like a node module that exports one singular function, and this is run on a container. This also means naturally there is no serverless as such. So this container runs a server of any kind, and this server reacts to incoming events. We will cover that a little bit later. So there are incoming events, and then this incoming event kind of triggers this function, and this function gets the data that is passed in and then does something with the data. So there is a server. You just don't have to care about the server. You just don't see the server as such. One important part of those of Lambda function is that they are ephemeral. This means they really are really short-lived. Here, the stateless kind of characteristic plays into that again. Very short-lived. They container really starts and stops as needed and can be disposed at any time. So you don't know how long this container will live, and it's also really limited by those platforms like AWS, how long you can keep a container alive. You could, for instance, kind of have a timer task that kind of forces this function to live on, but that's not the purpose of it. A typical use case would be, for instance, I'm working with the Dynatrace Davis team. We're doing natural language processing, and when it's about date parsing, so you can now, meanwhile, with Amazon Lex, what we use for our natural language processing, you can have one intent, or one phrase that comes in that you can then send off to Amazon Lambda, and that does the processing there. For instance, we use that for data processing in a way that if someone says, what happened on Monday, we will translate this back to last Monday, because usual date types, when someone asks about Monday, in usual natural language processing implementations, this always means last Monday. So we get Monday, and then we do the date transformation for that. And you can set this directly in Amazon Lex. You can say when a weekday comes in, send this whole phrase off to Amazon Lambda and work with what you get back. So that's a typical use case, and that's very small.
It's a very specific method, very specific
function. Or you have, in times of all those single-page applications that just are sent to the browser and then run on the browser, you just maybe need a function to put something in the basket, or like when you have a shopping system, you have this add basket, and this calls a Lambda function that gets an item ID or item number and a user ID most probably, and puts that into some queue or database that then gets processed asynchronously in a way. So that's the thing. Yeah.
Okay. So I think I better understand now. Keep it small, keep it simple, and a function has typically a small, time frame, or like a lifetime, right? I think this is also the way we are charged.
Exactly. Yeah.
Right? So Amazon, or I'm sure also Microsoft, the same model. So
that's a very, I would say. it's a very economic way of using resources. After all, it's resources. It's also like, let's put it in an environmental context. It makes a difference if I have a server running like 24/7, doing nothing for maybe 30% of the time, or you have a server that kind of runs every time, only just starts on demand. And this is what functions actually then provide. I know that this already is kind of also provided by some platforms of as a service systems, for sure. With Lambda functions, for instance, this is already kind of part of the DNA, because you cannot rely on this thing running at all or running, but it will start up very quickly, so you won't have much of a problem when it has to start fresh when you do something. Yeah.
So, and again, to reiterate, as a developer, if I use serverless or function as a service, which I believe is a much better term, because there are actually obviously servers there, but just managed by somebody else. As a developer, I can write a function. Most prominent language is Node.js, right? But
Java is available as well.
Java is available as well. Yeah. Anything else? Python?
I think currently I just saw Java and Node.js.
I would assume Microsoft is probably doing something .NET specific.
Yeah, but
which makes sense.
Microsoft also has I have to confess that I didn't look so much into this.
Okay.
Yeah.
So, but I write a function, and the function, as a developer, I should write efficient code, because I will be charged by, let's say, Amazon, when we talk about lambdas, by the number of times the method is invoked, but also how long the method runs. And that's a critical thing. Okay, and it kind of reminds me of, even though I've not lived through that period, I'm not sure if you have, but for the mainframe period, where the mainframe has been charged by the number of MIPS, the millions instructions per second. So that means a very inefficient program also means more MIPS, meaning you have to pay more money.
Exactly, yeah. And this is also, I think we covered that, or we can cover that now, also a challenge for everything that is monitoring, for instance.
Yeah.
So, because when we do monitoring on a Lambda function, we really have to be careful that we don't let the Lambda function run too long just because of monitoring to send off our data to the server or so. So we have to be also, from a monitoring perspective, very quick in kind of releasing that function again.
Yeah, so, of course, because otherwise you hold on to it, and which means in the end the developer, the company, whoever runs the function, is actually charging extra or being charged extra because of monitoring.
Because the monitoring solution does its housekeeping, etc.
Yeah.
So we are really working towards that topic currently, and really working on doing that right, because it's really something you have to find a way to flush out really, really quickly before this Lambda function dies or freezes. So otherwise you can do two things. You can keep this function alive artificially, which means, that costs. Or you let it run and then it freezes, but then you don't have the time to flush out the data in time to the server, which means that you may lose transactions here. So that's something that has to be tackled from a monitoring perspective, and there we also see how young this whole topic is, because that's something that is still in development, also from the vendors. That's something that has to be covered, but is not currently not here already. So
that means the only official monitoring that exists right now is through what the vendor provides. Like in Amazon's case, it is through CloudWatch.
Yeah, exactly. That's what's there. But we already managed to monitor Lambda function. We see a node application. We see also what the running application. That's not really a problem at all. The only thing we are now currently looking at is how to really be quick in finishing up our tasks, to not kind of keep this function alive in an extremely long time, or overly long time.
So not to get too technical, but how do we get into these Lambda functions? Because obviously you don't control the container, you don't control the server, you don't have access to that server. How do we do this?
So the good thing is that our one agent approach already. So usually, when you have Dynatrace, you install one agent on a server, and it instruments all your applications. And then you also get process metrics and everything else around that through this one agent, because behind the scenes, there is a host agent that gets all those host metrics then. When an application runs and it has an agent deployed to this application, you do this in Node.js, for instance, via using an NPM module and requiring this module then. This running agent detects that there is no host agent present and will then start to collect everything that can be collected from the user that is kind of that owns this node process. We will then collect host metrics as they come, as they are available for us, and there's plenty you can, because we are running, we have a JavaScript part and a native part, and the native part can, as also rather unprivileged user, you can collect some metrics. Yeah, and there you get all those host metrics. So this requires this one thing, host metrics you have then. What you don't have is this incoming transaction, because the transaction gets visible for us at the start of the Lambda function body when this gets executed. To achieve that, we have to you have to use something like SDK to collect, kind of to trigger the beginning of this Lambda transaction, so that it gets stitched to our whole pure path, so that this is initiated. And then you also have to end this at some point and say, okay, this was the Lambda function. So you have the timings and also this whole transactional tracing through this Lambda function.
Cool. So I remember 2 weeks ago I was in Boston at a serverless meetup, and I think I told you about this. We did it was more like a hackathon where we deployed it's what's called a zombie chat application. It was one of their workshop applications, and it was heavily using Lambdas. And so what you tell me right now, because I didn't do that, but this is interesting. So I deployed this app that was using Lambdas. I hooked up Dynatrace through the regular AWS integration, so pulling metrics in through CloudWatch. But additionally, the only thing I would have needed to do in order to get more visibility into these Node.js Lambdas is to simply include our agent, the module, and then when internally AWS is actually launching the Node.js container and loads my code, it will automatically also load our one agent.
Exactly.
That's proof. Okay.
So, and the good thing is that those containers are not started for every time you create the Lambda function. This means, so a Node application always runs in kind of two stages. The first stage is this whole parsing, when everything, also these require lines, are resolved and this code is required and started. And the other part is reacting to events. This means that when you kind of have a Lambda function that is continuously called and the container is not disposed during this time but just freezed, this means that you don't have this agent startup latency every time you start the Lambda function, but just, like every time the container is really newly created. But then you also have other latencies here as well. But this does not happen all too frequently. So I tried this. So I created a Lambda function and and accessed it over an hour again and again. And there you really kind of the whole agent startup or the overhead we are adding is really like so minimal that it's hardly to measure. So
cool. Wow, well, I just learned. I mean, I didn't want to go too technically, too deep, but this is perfect. So I wasn't aware that we're already at that stage where we can actually do tracing of the node.
Yeah, we have to. We see it so much at customers that it's really like a topic that we prioritize and that we are covering. Yeah.
Can you give me a couple of more use cases for which type of applications people use serverless or Lambdas? Because some people that I talk to still have a hard time understanding what type of apps they can build with functions, because we're still in this old development model.
You don't build apps as such with functions. Building up apps with functions, I think it's already a too big scale. After all, it's like doing some tasks with functions. For instance, like adding something to a basket, like writing something into the database. Pulling some data out of the database, reacting, and that's, I think, one thing we have to cover, that a Lambda function can be triggered by an HTTP call, but also can be triggered by some event on a queue or something coming on a queue, can be triggered by a database event, for instance, also, and acting like a little bit like stored procedures. So everything that kind of where you want to do one thing in reaction to some event is a good fit for a Lambda function. So, queuing stuff, for instance, of course, transformation, what we say, IoT, for instance, IoT devices sending arbitrary data to somewhere, and you need this thing to kind of collect the data and do something, but in a fire and forget way. Lambda functions are a perfect fit, because you can let the device send something to a Lambda function. This Lambda function puts it into a queue, or transforms it, puts it into a queue, and this queue gets then processed by something else.
And also classical batch processing, right? It's perfect.
Batch processing, something like that.
Yeah.
And so, but the problem here, as developer, I have to add this here now, is, of course, deployment and testing is difficult of such things. So deployment you can most probably automate in a way, but testing is a thing, because there is currently no way to have a Lambda environment locally in a way to kind of run local tests. So you always have to have this endpoint right when you do testing, and that's already always a problem when you have a microservice platform that really depends on many microservices and API REST calls it has to make. Creating a unit test, for instance, or integration tests is really difficult, because you then have to either have this endpoint available or mock this whole endpoint, and that also means a lot of redundant work.
But if maybe I don't understand this correctly, then I assume Amazon gives me the command line interface to deploy a Lambda, right? So I can automate the deployment.
You can automate, but it's a difference. So let's go back to monolith. As bad as there are, but you deploy one thing and it runs. A Lambda function, you really have to, if you depend on 25 Lambda functions, you have to keep track of them.
Of course, yeah. I mean, but isn't this where the API gateway comes also in Amazon, assuming that your Lambda functions can be accessed through an HTTP endpoint, for instance, right? Then you can mock certain services away. And then you could write it like a JMeter test that just tests the endpoints of this function. Yeah,
but of course, but that's not really like easy.
No, I know. I don't say it's easy. Yeah.
It's one obstacle you have more while developing.
And coming back to what you said earlier, it's a very young technology still, and there's a lot of stuff that is still missing, or that it's not convenient yet.
There is a lot of tooling missing.
Like debugging. Right?
Debugging is really a pain currently, because if your node function fails, you have some log messages, but it's really hard to figure out what's really going on.
But isn't that where monitoring tools like Dynatrace come in?
Yeah, sure, because we catch those exceptions. But if you don't have that, you're really lost. It's not like it works on my machine and doesn't work on Lambda. That can really be a problem to figure out what's going on here.
Also, maybe a little time reference, just so people know that listen to this. Right now, it's May 2017. It's a young technology. A lot of things is happening. Yeah. So maybe in a couple of months from now, in a year from now, things will change, right?
That's a field, also an interesting field to kind of get started with something or build tooling around that. So I would say it's exciting times for that,
And are we, I assume, though, we are working closely with the vendors to help them, to help us building better software, like defining interfaces, new things? Is there something?
Of course. Yeah. So we have a very close relationship with AWS, and even lately we were on the call with a product manager of AWS Lambda. So we are in touch, and we know what's planned and
That's nice.
See things coming. Yeah.
Perfect. Good. So if I can sum this up, serverless doesn't mean no servers. It just basically better is explained with function as a service.
Yes.
Building something that is small, that has one sole purpose. Perfect examples would be simple things like batch processing, putting something to a database, something that can be used from a single page app, or IoT was another great example, right, where this is used. And functions should be fast because you also get charged by that. What else did I miss? Is there anything else that I miss? I believe you shouldn't worry about the container. Obviously, underneath the hood, there's a server, there's a container that runs for a while.
It's very close to this 12-factor idea. It's stateless, very smaller than microservices. Yeah.
And it's, as we said, the tooling for everything is
orchestration is a challenge.
It's a challenge, yeah. Cool. Do you have any other final thoughts? Anything that we missed?
No, just as I said, it's an exciting topic, and I'm really eager to find out what's coming next year and how this whole thing develops over the next few months.
And just as a reminder for the audience, if they want to find more out about it, especially following you, what's coming out of the work that you're doing, what's the best way to get in touch with you?
Via most probably Twitter. It always works. Like, my Twitter handle is DKHAN for Daniel Kahn. Yeah, and follow me on Twitter and contact me anytime. So. Yeah.
Cool. And I guess people can also try out the stuff that we built as a monitoring. So for monitoring Lambda. And the easiest is going...
Almost. Let's say almost. We are working on that. Yeah. So it's currently in lab stage, but it will... I expect it also to be GA in a few months. Yeah.
And by the time this airs and by the time people listen to it, so go to Dynatrace.com and sign up for the free trial. Mm-hmm. That gets you a SaaS instance of Dynatrace, and then just follow stuff that you find obviously on our online portal about how to monitor Lambda functions.
Exactly.
It's all there. Cool. Thank you so much. Let's go back to the cool office here, which is actually
it's really cool. It's like post-industrial in Detroit.
Yeah.
It's awesome.
Detroit in transformation.
Yeah, absolutely. I like Detroit, by the way.
Yeah. Cool city. Come by if you've never been here. All right. Bye-bye.
Bye.